Alright, so now we're going to talk about expanding. So I've already done a video, there's another video about how to compress logs, and you write it as a single log, I believe. Now we're going to expand. We want to write it as a sum or difference of logs. And so what we're going to have here is your end result is going to have a lot of logs, and inside each log is allowed to be only one thing, and that is either a prime number or a single letter. So if you end up with log 6, well 6 is 2 times 3, that's not prime. You need to break that up into log 2 plus log 3. Or if you end up with log x squared, it's not a single letter. It's x times x. You can either use the power rule or the product rule to break that up. So at the end result, every log needs to have inside of it only a single prime number or a single letter. So if you have 2x, there's 2 things inside, not just 1. So you need to break that up into log 2 plus log x. Okay? The other thing to be careful in is if you do have a base, make sure that base gets written down every time. Make sure your answer, every single log has that base on it. That base applies to all the logs, not just one or not just none. Make sure it stays with you. Very first thing I would do here is I'm always looking to say, okay, what's the worst thing and how can I get rid of it? Because if I can get out of the worst thing, it's going to make my life a little bit easier. If I can get rid of it. It's kind of like if you're at work and you're doing a job. What's the worst thing? And let's see if I can pawn that off on someone else to do it. Well, it gets out of my worry, right? Maybe, sometimes. Alright, so here, my worst thing here is the radical. And that's the part most people just forget. They forget to do anything with that. I don't know if it freaks them out or if they just don't know what to do with it. But that's the part most often left not done. So I'm going to deal with the radical first. That way I don't forget to do it later. And make sure your z's don't look like 2's. This is a z. Okay? What I'm going to do with that radical is the type of radical can be rewritten as a fractional exponent. And the type of radical will be the denominator of the fractional exponent. So instead of a 7th root, I can put a 1/7 exponent. The denominator says what type of an exponent. So if it was a square root, it would be 1/2. If it was a 5th root, it would be 1/5. If it was a 24th root, it would be 1/24 as your fractional exponent. Whatever that is becomes your denominator. Okay? So that halfway gets rid of my radical. Now we have a fractional exponent, which is almost as terrifying. But with logs, we do have a property called the power rule. If I could write what I wanted. Log base a of x to any power. It's the same thing as p times log base a of x. So that power can jump to the front only when it's on the log. If it's not on the log, you can't do it. So this exponent can jump to the front. So this can give you 1/7 times log base b x squared over y to the 7th z to the 6th. That is a 6. Okay? So that 1/7 just became up front. Okay? Now we're going to break up the inside of the log even more, because I said it's got to be a single letter. Right now we have 3 letters as well as 3 exponents. So we still have a lot of work to do. Now multiplication or division on the inside is the same as addition or subtraction on the outside. Now a lot of people get that property confused. They get confused as to which is allowed to be on the inside and which is allowed to be on the outside. And the way I think about it is you can go and hang out with friends, and you can add to a group, or you can leave a group and subtract from a group, and you can do that all day long anywhere you want to, right? But if you're multiplying with another person, and you're multiplying and making more people, pretty sure it's illegal to do that outside. So for that, the multiplication, division part has to be done inside. The addition, subtraction is the part that's outside. So here, the division and the multiplication is inside. So if we want to rewrite that, we're going to rewrite it as addition on the outside. So this 1/7, that's 1/7 power, that's 7th root. That affected all three variables. So all three variables' logs are going to have to keep that 1/7. It's going to have to stay with them. So I'm going to break this log into one for each variable. One for my x, one for my y, one for my z. All separated by either addition or subtraction depending on where they are. So we're going to keep that 1/7 log. This one's going to be for my x squared. I'm going to get a 1/7 log base b for my y to the 7th. And I'm going to get a 1/7 log base b for my z to the 6th. So I still need the addition subtraction, right? I'm just starting to set it up. So the first log was an x squared, right? So we're going to look back up here at the last step. And you're going to ask yourself two questions. Is x squared on top or bottom? It's on top. Should the log be positive or negative? Anytime the variable comes from the top, the log should be positive. Anytime the variable comes from the bottom, the log should be negative to show that it was dividing. So x squared was on top. That gives us positive sign there, which we won't end up writing. Y to the 7th was on bottom, so it give us a negative sign. Z to the 6th was on bottom. It's going to give us a negative sign. That's how you can break up your multiplication and division. Alright, so now we need to look at the inside of every log. Inside this log I have x squared. So this log is y to the 7th and this log is z to the 6th. We still have multiple things. X squared is not just a single x. It's an x squared. It's x times x. Y to the 7th is not a single y. That's y to the 7th. Y times y times y times y times y times y times y. I lost count. There may be one more y. I don't know. It doesn't matter. We need to deal with the exponents and get rid of those. Exponents, just like we did before, we said they go to the front and they get multiplied. So make sure when you take this exponent to the front, it is multiplying. So you're going to come to your handy dandy calculator. I have a TI 84, 83s work the same. You're going to do 1 divided by 7 times 2, enter. We get a decimal. Decimals are rounded, we want exact answers. Math, enter, enter, 2 7ths. Notice it just multiplied by the top. 2 7ths. Log base b of x. Inside is a single letter, so that's good. Minus, same thing here. 1/7 times 7, that's just 1. Log base b of y, single letter. Minus 1/7 times 6. 6 7ths, log base b of z. Every inside of the log is a single letter. The only other thing you need to look out for is any properties. We have the property log base a of a equals 1. So anytime the base of the log is the same as the inside of the log, it would equal 1, or the base of the log is the same as the base of the exponent, it equals the exponent. You have the property of log of 1 is 0, and so you've got to watch out for all those properties to make sure they don't sneak in at the end. But inside's a single letter, single letter, single letter. If you had any numbers left inside, you've got to make sure they're prime. If they're not prime, break them up farther. Write it as multiplication and then rewrite it as addition.